there, everybody. We'll go ahead and let folks start coming into the Zoom room. And as people are coming in, I'll go ahead and direct you to the chat. The chat is how we'll be answering questions today. So make sure that you're putting your questions in there. We'll keep an eye on that. And we've got a pretty awesome presentation for you all. It looks like it's 4 o'clock now, so I'll go ahead and hop into our housekeeping items just to make sure we're making the most of our time together today. You will receive a recording of this webinar. It will be live on our website and on our YouTube channel in 3 to 5 business days. You'll receive an email with a recording link as well as a folder with additional resources and a certificate of attendance. So keep an eye on your inbox and we'll send that on over to you. We would love to answer your questions during today's session, so please do feel free to use this chat section in Zoom to ask your questions. We'll be monitoring it, and if we happen to not get to your question, please reach out to us at support@vernier.com. With that, I will hand it over to our fabulous presenters. Thank you all for attending.
Cool. So what we're going to do today is, I'm just going to go over the agenda. You're going to meet the presenters. That's the three of us. This is all about the CASE Vernier Science Education Partnership. We're going to talk about GoDirect sensors versus LabQuest sensors. And then we're going to be talking about what courses use Vernier sensors with CASE. And then at the end, there'll be some time about like how you can order equipment. Don't forget, ask questions anytime. Just put them in chat and we'll take care of them. So my name is John Melville. I got my PhD in zoology from Oregon State University a long time ago. I'm a former college biology professor. I taught for a long time. I'm one of just the lead biologists here, so I know a lot about some of the sensors that are used in the CASE curriculum. And I have a background in animal physiology, animal behavior and neuroscience, and a little bit of behavioral neuroendocrinology. That's not really that important. The most important thing is I'm a former teacher. And then you can meet Josh. Josh, go ahead and introduce yourself.
Hi, I'm Josh. I was a physics and engineering teacher at the high school level in Virginia for 10 years. Here at Vernier, I do all sorts of stuff like John. We help with product development. We do a lot of customer service type stuff. So if you have questions about probes or you're looking for training or you go to a conference, it's likely you'll run into one of us. I really love engineering as a way to teach science and math. And so I'm excited to talk to you a little bit about how Vernier can support you in your CASE classes.
All right. And then, oh, sorry, Chelsea.
All good. And for those of you that don't know me, my name is Chelsea Bowen. I've got a master's in ag education from the Kansas State University, and I also got my bachelor's in that as well. I taught CASE in a multi-teacher program and in a single teacher program in 2 different states, Kansas and Kentucky, for 8 years. And I've got AFNR, ASA, APT, and Ag Business certifications that I utilize my experience to coordinate with those teachers that we work with day in and day out. I'm currently the events and operations coordinator with CASE, and I work full-time to make sure that we're offering events that are going to work for our teachers and help them in professional development. And I've also been a CASE contractor as a master teacher, and throughout that process have gotten to lead a bunch of different institutes for teachers that are gaining that professional development. So I've seen things from both sides of the field, and I've gotten to use a lot of Vernier equipment as a result of that, not only with students, but also with teacher educators. So we're going to get started here and talk just briefly about the CASE and Vernier relationship and partnership that's been going on for approximately around 15 years. That's a really great milestone for us because we've always felt that we've had a great partnership with Vernier to be able to utilize the technologies and sensors that Vernier's been able to provide and incorporate those in the labs that we're able to offer through the curriculum. So the CASE for Learning curriculum package comes as 2 different envelopes. The curriculum is lifetime access once you purchase the professional development, and the professional development gives you that technical training that you're going to need to be able to utilize not only the Vernier equipment, but also the labs and the other technical elements of the curriculum to be able to deliver it to your students. So we started with the original LabQuest, and if anybody remembers them, they have definitely come a long way since then. But we started with the original LabQuest, and we're now to the LabQuest 3. And the original LabQuest had all the plug-in sensors, but now we have a lot more accessibility with the Go Direct sensors and the bring your own device option that they're going to talk about here very soon. So we're really excited about the partnership we've had with Vernier, and we just look forward to having another 15 years together and seeing all the innovations that come along the way.
Cool. Thank you, Chelsea. So what I was just going to briefly talk about is there's LabQuest, what we call LabQuest sensors. They're the older style sensors. And then there are Go Direct sensors. And I wanted to show you how to connect to a Go Direct sensor. But I also can just show you what I mean here. So let me just bring up my camera. Hopefully you can all see my camera right here. This is a Go Direct sensor. And this right here is one of our older sensors. It's got this like telephone connector cable on it. This is a wide range temperature probe. And you would plug the end of this into your interface. And that's what we refer to when we're referring to LabQuest sensors. Go Direct sensors do not require an interface. They connect directly via USB or Bluetooth, but they also can work with a LabQuest 2 or LabQuest 3. So you can also connect them to a LabQuest 2 or LabQuest 3. So just don't forget, if you already have a LabQuest 2 or LabQuest 3 and you get Go Direct sensors, that doesn't mean you can't use them. And they also work with graphical analysis. The one key difference is that your old sensors can be used with Logger Pro and graphical analysis. The Go Direct sensors cannot be used with Logger Pro. Just to remind you, the primary courses that use Vernier sensors with CASE are AF&R, which is the Ag, Food, Natural Resources course, Ag, Power, and Tech, which I believe Josh will be talking to you more about the sensors that are used in that course. There's also Animal Science, Plant Science, Natural Resources and Ecology, Environmental Science, and Food Science and Safety. And what Chelsea has told me is these are the primary courses that use Vernier sensors, but there are other ones that use them as well. Another thing that I would add is that if you want any help with any Vernier sensors or anything like that, don't forget that you can just get in touch with us, contact us, and any type of basic training, as long as it's under an hour, we'll do for free over Zoom virtually. So feel free to get in touch with us if you have any questions. All right, so what I wanted to just briefly talk about is Go Direct sensors and how they're used. And I just wanted to, this slide that I've got up here, I wanted to just remind everybody that Go Direct sensors have to be used with graphical analysis, or they can be used with LabQuest. I think the big key 3 sensors that you use are the Go Direct temperature probe, the Go Direct CO2 probe, and then the Go Direct pH probe. One of the things that I wanted to talk to you about with the Go Direct CO2 sensor, though, is some of these sensors are what we call multi-channel sensors. So they can do other things besides just measure temperature. They can also measure relative humidity and things like that, and I'll show you how they work. But the big thing is the Go Direct sensors, you can connect them via USB using a USB cable, or you can use them wirelessly using Bluetooth. They all are going to have a really simple calibration procedure, or maybe not even require calibration at all. And then the software that you need to use would be graphical analysis, which can be installed on a phone, tablet, Mac, PC, even a Chromebook, but it will also work with your LabQuest. So just to get back to the CO2 gas sensor, I just wanted to remind you that this is one of those sensors that is a multi-channel sensor, so you can use it for many things. And then just briefly, hopefully I'm not going too fast, I want to just show you how to connect it using graphical analysis, and then show you how to connect it using a LabQuest 3. So that if you have any questions, you can, hopefully they'll be answered. So let me just switch over to a live demo of a camera view. We've got a live down camera view here. Widen that up a little bit. So here is the Go Direct sensor right here. You can see that the Go Direct sensor at the very bottom has a USB port. It also has a button right here. This button would turn on the Bluetooth. The simplest way to connect it is actually going to be to just plug in the USB cable. and then take the other end of the USB cable and plug it into your computer, which is what I'm going to do. And then I'm going to launch graphical analysis. And here's what you would do. If you launch graphical analysis, I'll just launch new experiment. What you should see here is it's going to say, hey, sensor data collection, is that what you want to do? But if you look in the background, you can see it's already identified the sensor. The CO2 sensor is already attached. It's already there. Just select sensor data collection. And there you go. The CO2 sensor is attached. Everything is ready to go. Let me make this a little bit bigger. The app preferences for you so you can see that a little bit better. And you can see that there's a live readout of CO2. It's all ready to graph. I could collect data just by hitting the collect button, etc. To show you how to connect over Bluetooth, let me just show you that really quick. So I'm going to disconnect from USB. You'll see that the CO2 sensor will go away. And then I'm going to do new experiment. And I'm going to go back over to the video. What I'm going to do here is, it looks like I've already pressed on this button. And you can see that it's flashing red. When that red LED is flashing, that means the Bluetooth is broadcasting. So to connect wirelessly, I would just go over, launch graphical analysis, select sensor data collection, and then it'll actually show me the sensors that are available. And you can see it says GDX CO2, and then it's got a bunch of numbers and says 1920. Let's go back to the camera view. If I flip this sensor over, you should see it says right there, there's that 1920, 0Q401 1920. So we know that this is the right sensor to connect to. So I'll connect to it. And there you go. I'm ready to collect data. If you're in this channel view, one of the things that you can see is if you tap on this little arrow up here where it says sensor channels, that's where you can turn on these other channels at the same time. So if you wanted relative humidity or temperature, you could do that. And so that's just how to connect over USB or Bluetooth. You just hit the collect button. I'm going to blow on the CO2 sensor. See, it goes up. So it should be that easy to use. Hopefully it'll be that easy for you to use as well. So just let me hit stop here. Close this really quick. I don't want to save anything there. And then what about if I wanted to connect, let's just go back here. So what if I wanted to connect to a LabQuest? Well, let me launch some software. I've got a LabQuest 3 sitting right next to me right here. Let me launch it here really quick. There, let's launch it again. Or I could do it the easy way. Hold on here. Let me just do it this way. I'm going to go back to my video. Here's a LabQuest 3. You can see right here. All that you have to do, same thing as you can just plug it in, plug in the USB cable. There's some USB ports on the side of the LabQuest 3. Plug them in. And there you can see CO2. It's all ready to go. There's another way to connect via Bluetooth. You could do that as well if it wasn't connected. You would just tap on sensors and then go to wireless device setup and then tap on go direct. And it's going to show you that same number, 1920 there. Hit connect, hit OK. And it'll connect to the CO2 sensor. I don't want to belabor that too much. All right. So let's just go back here. So it should be really easy to connect your GoDirect sensors to a LabQuest 3, graphical analysis, etc. Just don't forget that you can still use them on a LabQuest. Did that live demo there. So just to get back to some specifics, for the Ag, Food, and Natural Resources course, AFNR, the big key sensors are go direct temperature, our go direct pH, our go direct CO2 gas, and then some other noteworthy sensors that are really cool. We do have a go direct oxygen gas sensor, go direct conductivity. We also, it's just brand new, we have a PAR sensor, which measures photosynthetically active radiation, which is the amount of light that's required or available for plants to do photosynthesis. It's great for ag. And coming soon, we will also have a go direct soil moisture sensor that should be great. And with that, oh, and then before I hand this off to Josh, I just wanted you to know that there's a great webinar on our website. This is a link to it right here. And this is a link to a webinar that my colleague Sarah Talarovic did with Chelsea, and it's all the tips and tricks that you need to know about how to take care of your sensors that you've got with AFNR. Goes through all the basics. So that's another great resource. You can just get to that by going to our website and checking out videos or webinars, and you'll see it there. All right. And with that, I will hand it off to Josh.
Thanks, John. I'm going to share my screen here.
Let me stop sharing and then go ahead and share.
Okay. Oh. Are you seeing my screen there? All right. So John went over a number of the sensors and that sort of thing that you would use for some of the more of the life sciences courses. I'm going to focus a little bit more on the ag, power, and technology courses. There are a number of activities that use our probes and sensors, and I'm going to focus on a few of them. We have lots of toys, especially when it comes to physics and engineering. And so I'm gonna start with this particular activity. It's called Bernoulli's Blades, and in it, students build blades that they then test, to see which design leads to the greatest power output. And I love this kind of activity because it's very hands-on. Students get a chance to actually physically make blades and stick them in there and kind of use their best guesses. And it's the kind of activity that it really does follow the engineering process where they get a chance to iterate on their designs. And it's an activity that's full of rich context. I don't know about you, but I feel like every time I go for a long drive, I see a new wind farm, that's sprouted up over there. And you see those blades turn, and you got to wonder, like, why do they always have 3 blades, and why do they shape that way? This is an opportunity for students to really kind of get into that and think about it, and have a chance to play around with the science and engineering principles behind those wind farms. So the things that this lesson uses are this wind turbine setup. This is a product we developed with a nonprofit called KidWind. KidWind is all about renewable energy education. We make a lot of stuff for them. And this particular kit, it comes with a tower. It comes with this nice hub, which allows you to add or remove blades as quickly as you want. It comes with a generator and some gears that you can use to connect the two together. And for the most part, students are going to be designing these blades. This is kind of like the most boring blades that you'd ever use, but this is where they usually start, and they might test it out and then make some modifications and decide, see if they can't get more power out of it. The lab, as written, uses, in order to measure kind of like the power output, it actually uses this sensor, which is called a rotary motion sensor. It measures how quickly this wheel turns. And the way that it accomplishes that is you actually remove this gear on the outside here and instead put, this is just a spool. It goes on on that axle, and then the rotary motion sensor mounts next to it. So the spool and the kind of the rotary motion sensor pulley rub against each other. And as the blades turn, so does the rotary motion sensor. That works well. I want to show you a couple of other options as well. The way this, you can also use, this is PhotoGate. It's actually like a LabQuest PhotoGate. And we have a special mount. It's just a photogate bracket that mounts to the turbine itself in such a way that it kind of watches, it measures this large gear here. So as the turbine blades turn, the gear turns, and the photogate beam is blocked and unblocked as the gear turns. That's another great way to measure rotational speed. You know, this probe, you know, they'll usually measure in revolutions per minute. The photogate likewise can measure in revolutions per minute. Another possibility, so there's the rotary motion sensor, there's the photogate. Another possibility to measure is actually to measure the direct power output. You know, there is a little generator in here, and it's going to produce a voltage, and it's going to push some current, and you can measure that using this Go Direct energy sensor. It measures the voltage, you know, that's being produced and the current, and then it will give you a power output. So it actually in milliwatts, and it really is milliwatts. It's very small, but it's kind of cool because you get that direct measure of like how much power is being produced. This actually has like a load built into it. You can, if you want, you can connect an external load to it. So if you wanted your wind turbine to run an LED or something like that, you could hook it up that way and still measure the power output. It's really you know, either, no matter which way you measure it, this is really one of those activities that allows students a real creative way of exploring a scientific principle here. There's energy transformations, and it gives them some experience with the engineering process. So that's it's called Bernoulli's blades. That's that particular activity. I'm going to switch this one out now and talk about another one, another engineering project. And that is the structural strength activity. I'm going to move this guy. So this particular activity.
There you go. Much better.
There we go.
Thank you so much.
Just had to catch the camera. So this structures and material tester gives you a load, a weight, a force measurement, but it also gives you displacement. So it'll measure how much your particular structure is being bent or deflected. Just like all of our Go Direct products, it will connect via USB or Bluetooth. I have a little bridge in here right now. You'll see at the bottom, there's kind of like a wheel here. That's actually how you apply the load. And it will measure in newtons or pounds. The deflection is usually in millimeters, but you can also get inches. It's a great way to allow students to explore. The primary advantage to a device like this over just loading up a bucket of sand is it's a little more refined. You can add the force, you can add the load as carefully as you'd like. And that allows you to really catch like what is that peak force. You know you haven't overshot it. Also, you can watch your structure as you load it up, and you can very quickly, easily see where the weak points are. And you know, usually in a project like this, you want to give them that chance to iterate and to think about to get and try again. And so if they know, well, this is what happened as I loaded it up, I saw it started bending at this joint, or it started coming apart along this beam right here, they have an idea of what they want to do differently that next time. This is primarily designed around structures like this, like a bridge, but these braces can be moved in and out. And so some folks will test towers, you know, you can use it. You can mount an individual truss in here if you want to go and look at the strength of an individual truss. There are lots of ways. We have some folks that have actually done more materials testing. They'll mount like a piece of chalk in here and have it. They'll look at how the breaking strength for a piece of chalk, or they'll mount something stretchy in there, and they'll look at the amount of stretch per force, you know, to get an elasticity. It's really opens the door to lots of activities. All right. I'm going to switch now to a slightly different camera here and talk about a couple of other activities. These. All right. It is fluid pressure. And so there are actually two here. There's one that's called fluid pressure, and there's another one that's called hydraulic lift. And it uses a pressure sensor. So I have here a couple of syringes. I had one of the chemists help me out today, and we put just food coloring in here so you can see it a little bit more. This is a 60 millimeter or 60 cc syringe, and this is 20. And they're connected together by way of a three-way junction here. This is really the three-way junction is so that you can attach the pressure sensor as well. But you could do this qualitatively just with one piece of tubing connecting the two together. And this is really like any sort of hydraulic system. You know, you apply a little bit of force here, and that force is transmitted by the fluid to the other syringe. And this is kind of one of those great discrepant events. You can have your students, you know, they say, okay, I'm going to push on one, you push on the other. Which one do you want? And they're going to be like, oh, I want the big one. Give me the big one. And they'll very quickly realize that they made the wrong decision. You know, and as you push and pull on these, you can actually measure the change in fluid pressure with the sensor. That's kind of how the lab works. Is they have this set up where you clamp one of these in a vise and add like a 2 Newton weight to one side, and then on the other end you press with the force sensor so you can measure how much force do I have to exert to lift that 2 Newtons over there. That's kind of how it's designed. This is really that principle is really what you're getting at. But if you want to talk to you want to grab your students, you talk to them about the brakes in their car. You know, this is the same way the brakes in the car work. And you know, if you've ever had to bleed the brakes in your car, that it can be kind of messy. Like, why do you do that? Well, it's because air gets into the system, and you can actually simulate that here. You can pull off, you know, especially if you're very careful. I mean, it gets really messy sometimes. You can pull off one, and you can let some air in, and then put it back in, and then you have a column of air in there, and you can measure the change in the pressure by having that column of air there. They can watch it as you squeeze this. So you can see that column of air will compress first before any of the fluids start moving, and you can get it. Really makes it easy to see like why that's important. You know, it really connects that everyday experience with the science principles that you're discussing. So that's fluid pressure, and like I said, the other one is called hydraulic lift. And again, in both cases, they're looking at this pressure force surface area relationship and mechanical advantage. And then that leads me to the last activity here. This one is about pulleys. And it uses our force sensor, and it is also all about mechanical advantage. It's this way. So you usually start off with just a single pulley, but the idea is this is a known weight here, and as you pull on the force sensor, you can see how much force does it take to lift that weight. This particular lesson is called, I think it's just called pulleys, pulley work. And you look at how much force you have to exert to lift the pulley in different, or to lift the weight in different pulley configurations. Students measure the force using the force sensor. This is the Go Direct force and acceleration sensor. It is just like our dual range force sensor, but it also includes a 3-axis accelerometer and a 3-axis gyro. So you can use it for other sorts of investigations as well. And it is, you also measure the distance, how far you're pulling and how far it's lifted, that sort of thing. Again, this is one of those activities where if students have ever used a pulley in real life, it really helps them connect the dots. In this slideshow that we'll share with you here, I've put all these sensors into links to these sensors and kits and stuff like that into this slideshow. You'll have that available to you here. One thing to note is that pressure sensor, comes in 2 different versions, one that's compatible with liquids and gases, and one that's only compatible with gases. You got to get the one with the liquid because you don't want to drown the poor gas only one. So, but otherwise, you know, just like I mentioned, all these probes they're great. They're really versatile. They give the students a chance to really do hands-on science and engage with the principals, collect real data. That's really a wonderful thing. John, you're still muted.
Yeah, I just realized that. I was just gonna say, does anybody have any questions? If there's any questions that we can answer, we'd be happy to do it. And just remember that you can always get in touch with us by just emailing support@vernier.com. If you want to go through any of the things that we've done recently, or just have a brief, less than an hour session training, that would be free too. Just get in touch with us, and we'd be happy to do that. And thank you so much, Chelsea, and Case, for this wonderful relationship that we have.
Yeah, for sure. So we can watch for those questions in the chat. If we want to hop to the next slide, let's talk really quick about ordering equipment, because the best part about our relationship with Vernier is not only the support that we get from you guys, but also the partnership that we have, giving our teachers a little bit of a discount when they attend a CASE curriculum training and then go to claim their savings when they go to order equipment. So having such a positive partnership has assisted us to provide a lot of different classrooms with this Vernier equipment, not only through the implementation grants that we have, but also just through providing a discount for all schools that have CASE certified teachers. So if you want to click ahead, Melville, the very first thing that a teacher is going to need to do is log in to their MyCase account. You can access materials on our website on the main page in the top navigation, either by clicking materials, or also right now we have a promotion on the front page, and that will rotate in and out depending on ordering seasons. But you'll see that you get a 3% discount on LabQuest and GoDirect products through ordering off of the CASE for Learning website. It's also important to note that you can also contact Vernier, and they're familiar with us, so they'll honor that discount regardless as to whether you order it on the site or just call in your order. But we're going to go through the methods of which to see and review materials, maybe make a purchase order requisition, and then also be able to complete your order on our site. So the next slide is going to show us where you can log in using your MyCase account. If you don't have a MyCase account, MyCase accounts are free, and they require nothing other than just for you to create a profile. And this is going to allow you to see all of the materials list for either all of the curriculums that we have, or you can view them by vendor. Since we're talking about primarily Vernier products today, I'm going to talk about reviewing products by vendor. So on the next slide, you'll see where when we click on products by vendor, we can, and this is an example of material by curriculum. So you would go to AF&R and then scroll down and you'll see where you have 2 options. And it's important to kind of make the decision as to what type of interfaces you're going to utilize in your classroom with Vernier. If you're going to go the traditional route, if you're looking at a curriculum that has a lot of the plug-in sensors, then you might need to invest in LabQuest so that you can support those sensors. So the Vernier LabQuest are going to be in black and white, and the Vernier GoDirect is going to be the logo that is in green and white. And it has a little bit of imagery there to kind of help everybody understand where to go. On the next slide is when you click by vendor, I believe. And that's when you're going to see all of the Vernier equipment. This one's an example of just the LabQuest order form. And you'll notice in the columns off to the right, we have all of the quantity recommended for each of the courses that we have published materials list for. So not only are you seeing AF&R like we saw just on the last slide, but you're also going to see the other courses that are utilizing this equipment as well. So if you are a program that's going to offer multiple CASE courses, this is really going to help you and give you a little bit of advantage so that you can work on your materials list all at once. There's slider bars on the far right side of each of those pieces of equipment. Say you only need to order LabQuest this time, or you need to order soil moisture sensors. You can select which ones are pertinent to you, and then it'll take you and progress you into the next section, which is going to take you to quantities. So on the next slide, you will see that you can go in and enter the final quantity that you want. All of those quantities are suggested for each of those courses based on a class of 20. So we try to help you understand with most of the labs, if it's going to be broken into a group of 2 or 3 or 4 or more, how many reasonable amount of sensors you're going to need for a classroom of 20. So that might change a little bit and fluctuate depending on if you're a small school or a large school, or if you've got a large class coming up. So just watch that before you put in your quantity needed. Once your quantity needed is in, your line total will sum, and then you can either place an order directly on this form, or you can also get a quote so that you can download for your purchase requisition. Once you've placed the order and you have to hit that submit choice button, it will prompt the order to go through, and then you should see the Vernier order confirmation email that we have an example of. And at that point, your order is confirmed, but Vernier is going to review it before they invoice anything. So on the following screen, I've given you an example where you know for sure that your order is confirmed and you're going to be invoiced. It'll have an attachment of a PDF that you can utilize and supply to your accounts payable or to whomever is in your billing office that's going to handle processing that invoice and getting that paid. And just another note, because I was talking with Vernier Ordering the other day, if you want to pay by credit card instead of by purchase order, you can always do so at any time. You just need to call into Vernier and reference your CASE discount. If they need to verify anything, they'll probably contact me and I'll get that taken care of so that they know that you're a teacher with us. But Vernier has always been very supportive of our teachers and very supportive and helpful of our teachers when we try to make orders or we have questions or inquiries and need support. So the ordering process is fairly simple. It's going to guide you through on the website, but you can always reference back to this video if you didn't get to attend live today to look through that process. And you can also contact us if you ever have any questions. And then Melville, did you have this link in there?
Which one? The sensor maintenance and reference guide?
Yep.
I don't know. I don't know that I did, but I could click on it and see if it.
This might have been one from the last that we felt was a really good tool from the last webinar that we did.
Oh yeah, and that's actually got all of the links on all of the things that you would need for sensor storage. That's a really nicely done there for category topic. It's a list of what we call our tills. So it's all of our things that you would need to know. And it's organized by color even, which is just gorgeous. So that's just another resource that you can get access to. So there you go. So any other questions?
And I think the last slide has all of our contact information on it. So if you ever need anything, any help for CASE curriculum or any questions about the curriculum and the curricular aspects and how we use Vernier, feel free to contact me. My information is there. And I'm also listed on the contact CASE page of our website. You can email, call whenever you need. And if you access my email, then you'll be able to access my calendar and just book a virtual meeting whenever is beneficial to you guys.
All right. Yeah. And then just don't forget that if you need to get in touch with Vernier, you can email us at support@vernier.com. You can also call us at 1-888-837-6437. And you can also chat on our website. So you can probably find Josh and I there on most days. And just thank you for coming.
All right. Thanks, everyone. Have a great rest of your week.